Well, I was trying to tap that with a chisel. That wasn't working. Trying to catch the edge there. I just can't. It's too deep down inside past this edge of this wall here, so I can't get the angle right. And I was going to try and make a socket to fit it. I have this piece of stock here that OD I can just leave the way it is, bore the ID so it slides down over this, and then just grind the face to leave a couple little tangs to try and lock in there. That was the plan. The problem is this won't fit my Atlas lathe. It's too big. If I try and open the jaws up far enough to grab this, then the jaws are way too far extended. Not to mention this doesn't fit down into the chuck, so it would also be extending outside of the chuck too far for a boring operation. So that's not going to work. What I need is, I either need to get one of these sockets, which I'm not having any luck finding, or I need to make one, which means I need one of my bigger lathes running. It's kind of a pain because I really hate the idea of having to abandon this project of the Wells Index Mill, leave it all apart, and then move on to a lathe assembly, but I don't know. I might just have to do that. Hey everybody, it's been a couple of weeks since I've been down here in the shop working on it, and I just haven't had any time. And this Wells Index bearing situation, getting this thing apart, has really been bugging me. I finally went to the auto parts store and rented the bearing socket set, and this is the only one that's even close. It's not close to this one on the top, but what I noticed that I didn't notice before was that this is a different sized one on the bottom here. The grooves are actually bigger. So my thought was if I took that bottom one off, maybe I could drive it out this way. But the problem is I can get this socket down in there to engage it pretty good. It seems like this OD of the socket actually gets kind of stuck inside there. And I'll tell you, I tried cranking on that thing. I swear I got it to turn a little bit, and then it stopped dead again. And so then I even tried the impact driver on it, which probably wasn't a good idea, but it still wouldn't budge it. So then I began to doubt whether or not that that nut was even threaded. You know, that could be a reverse thread on that nut. I don't know. So in desperation, I decided to try something I had tried briefly before but didn't have any success with, and that's just using a punch like this and catching the edge of one of those slots and tapping. And sure enough, I got it to start moving. The interesting thing is, I've moved this, unscrewed this quite a bit now, and it's still tight, which tells me that I believe that nut is made in such a way that it's self-tightening or self-locking. I mean, it's just finally starting to get a little bit looser now, but that's because I'm already, the top of the nut is already past the top of the threads a little bit. It's a very fine thread. There it is, there's the nut. Now I can buy this nut online, or from actually even Fastenal can order me one of these nuts. So I'm not too broken up about the fact that I really did a number on that thing with the punch, because the exact socket that fits this, even if I can find it, I'm getting ridiculous prices, like $300 for one socket, and I'm not kidding. I mean, literally, that's what they're pricing them out at. Alright, so I see a bearing shield on the top here, a removable one. I think this is supposed to just go out that way. That's it. So there's the spanner I was just trying to take off with this nut from the auto parts store. And yeah, it looks like, yeah, that looks like that was actually a good fit. This is a power built 4 lug by 2 3/8 cutter spindle nut, 648473. So that's for a bearing retainer nut on some kind of an automobile. But now that I have this out, I can see why I couldn't get this out. There's a metal shaving right there where this snapped. But that's all rusty. It's all rusted. Big time. Water sitting in here. So up in here we've got a bearing. Well, my understanding is I think there's another pair of bearings up here. Yeah. Looks like one sitting right on top of the other. So I found some bearings with different suffixes but the same dimensions. These are angular contact ball bearings, and I did find a couple online, new old stock, relatively cheap. But what I found out was that the bearings that are in here are actually special precision matched pairs of bearings. Wells Index has these bearings in stock. They're $300 a pair. You get a pair down here and a pair up here. $600 in bearings. I told him about how my spindle is snapped, and he said to me, he says, "Is it R8?" I said, "Yeah." He says, "Well," he says, "then your drawbar is what's been holding it together this whole time. Whenever you put the drawbar in, tighten everything up, basically that broken half tightens up against this and keys into this, and that's how this has been running all these years, because that's probably been broken for a while." So I got three alternatives. Alternative number one: buy a new spindle. Wells Index can sell me a new spindle for this machine. He didn't have the parts book in front of him, but he said, yeah, it's about $850. So $850 for the spindle, $600 for 2 matched pairs of bearings. You know, somewhere around $1,600 I could put this all back together, and the spindle anyways will be like new. That ain't happening. Option number 2: I fixed this shaft by taking this apart, putting the 2 pieces together, grinding a groove out, TIG welding it all together. The problem with that is this surface right here, right where this snapped, is right where one of the 2 bearings rides. So that's a precision machine surface right there. If it had snapped up here, I could monkey around and weld this all up, and it wouldn't even have to look pretty because there's plenty of room inside that bore down in there. But no, it snapped in the worst spot as far as I'm concerned. Option number 3: I put this back together with this shaft, and I just rely on my drawbar to do the job that it's been doing all this time, and I think that's what I'm going to try and see what happens. You know, worst case scenario is if that doesn't work, I'm going to take it all apart and go with some other plan. And as far as the bearings go, I'm basically stuck between the ultimatum of taking the old bearings, cleaning them as clean as I can get them, packing them, repacking them with new grease and putting them back in, or buying the non-precision matched pair of bearings that I found online, and those would be brand new bearings, and putting those in. So I haven't quite decided yet what I'm going to do. But at least tonight I was able to get that nut out and also get that spindle out. And the bearings are going to be, let's see. Actually, it looks like they'll probably just knock out from this side now that I got that out. One. There's two. Oh man. Is it any wonder that bearing sounds the way it does? That's just rust, water, nasty. Well, I got work early tomorrow. I gotta clean up and call it a night, so that's it. Might be another week before I get back down here. Well, I decided I'm gonna reuse these bearings. I've cleaned them up really well, and they sound pretty good, considering there's no grease in them right now. And as far as I could tell, looking on the magnification down in there, there isn't any severe damage that I can see in there, and I did clean them out really well. It took quite a bit of cleaning to get them as clean as this, and they're precision bearings, so they're not supposed to be, you're not supposed to put them in an ultrasonic cleaner, for instance. Read that somewhere. And there's other things you're not supposed to do to them. So I did my best to clean them without damaging them, and only time will tell. So what I'm going to do is I'm going to repack them with grease. Now these are the two bearings that are supporting the upper part of the spindle. So these are probably, of the two types of bearings that are in here, these are probably the less critical. These two bearings are directly up against each other, as opposed to these two bearings actually are the ones that support the end of the spindle closer to where the, well, basically where the collet's going to be. So these are going to be more critical. I also clean these up really well. Again, Wells Index wants $300 for a pair of bearings, for this pair of bearings, and $300 for this pair of bearings. And I'm not going to do that at this time. And I did find some cheap bearings online here and there, but these are precision matched pairs. What I thought was marks where the bearings had been rubbing against something or like spun is in fact more than likely trace marks from a light bit of grinding that was done on the bearings. And the reason for that is that bearing, grinding those bearings a very precise amount, allows them to be the proper height so that when that nut is tightened down, it sets the preload on the bearings precisely without any shims or anything like that. The type of grease specified by Wells Index is Mobile Grease 28 synthetic aircraft grease. This is a grease with a clay thickener, and there are some numbers on here that you can find other greases that have that number, but I actually called and spoke to somebody at the Tech Assist line at Mobile to try and understand what it was that made this grease special. The reason why I did that was because I was having such a hard time finding a local supplier for this grease. My bearing supply didn't have it. I finally found a distributor. It's only about 30 minutes away from here, and they did in fact have the grease, but unfortunately they're a distributor, and so they would only sell it to me if I was willing to buy 10 tubes. I think there's 30 tubes in a case, and he said the minimum buy would be 10. Obviously, this one tube that I ended up buying online is probably going to last me forever. So anyway, so I couldn't buy it locally anywhere. So I went online. I found it on Amazon, and typically this goes for about $30 for a tube, and then there's shipping on top of that. But I found actually on eBay, I found a guy who was selling these, I think, for about 22 or $23 a tube, and I think that might have even included the shipping, or it was the best deal I found for this grease was on eBay. This is a aviation grade grease apparently, and it has something to do with this grease being a very light grease, I guess. I don't remember all of the specs. I learned more about grease than I'm ever going to want to know again in my lifetime, and I've now forgotten most of it because I got the right grease. At this point, I'll also mention the other grease that was suggested by a lot of people online for spindle bearings in any milling machines would be, I believe, a product called Isoflex, made by a company called Kluber, I think, Kluber, I believe. And that is apparently the magic grease that is so awesome. It is crazy money. It is sold by the CC. It's basically, you might as well, you're going to have to go and see a street level dealer to score that kind of smack. I'm not going to do that. I got this stuff, and this is what we're going to go with. So now I'm going to talk about putting the grease in. So I was reading online about putting the grease in bearings, and I learned something that I didn't know. I always thought you pack the grease in and you push this grease in until it squeezes out the other side and you fill this whole cage with grease. And well, it turns out, at least for this application, that's actually not the proper way to do it. That you don't want to pack it up with too much grease. You can actually overload the bearing with grease, which can cause the bearing to actually run hotter than it's supposed to and lead to premature failure of the bearing. So that's something I absolutely did not know. And there's a couple of ways you could do this. I'm going to try using this little plastic syringe that I have. This is actually a medical grade syringe. It's supposed to have the syringe part, the needle actually sticks on here. And if you unscrew the needle, that gives you a pretty decent size hole right there, which actually looks like it's going to be the perfect size for going right in here into this groove. So I'm going to use that. My problem is loading this. We'll see how that works out. The other way you can do it, I watched a YouTube video of a company that rebuilds, apparently they rebuild Bridgeports and replace the bearings. They were explaining how to replace the bearings. So they showed how to take it all apart and put it together. And they showed when they unpacked the brand new bearings that what they did was they had some sort of grease that was in a little container that was red. Interestingly enough, I think this stuff is red. And so the kit that they sell you comes with these high precision bearings and a little cup, like it's almost like a to-go cup for your tartar sauce when you get takeout fish and chips. And it comes with this grease in it. And what the guy did was there's two sides here. You can see there's a very narrow groove there, and then obviously this is the side with the open side. So this is the side you want to push the grease in from. And what he did was he took some grease on his fingers and pushed it, and he packs it in and pushes it in with his thumb. Of course, you wear gloves until it squeezes out on the other side. But what they said that you should only do a quarter to a third of the bearing. So in other words, if you started packing it in over here, you'd probably only want to go from here to here, or from here to maybe here at the most. You wouldn't pack the whole thing. The idea being is that if you pack the grease into this area right here, once the bearing's rotated, the balls will move around and actually start to redistribute that grease. That's what they're saying. And that's how you go about getting grease throughout it without overpacking it. And then there's method number 2, which I heard about online, which is a syringe and just a little squirt, a little dollop in between each opening. And that's what I'm going to try anyways. So I don't want to pop this. If I was putting this in a grease gun, of course I would pop this off, drop this down into the gun, and then take the back cap off here. It's a lot darker than I thought it would be. But it is that red color. So now I'm wondering whether or not this grease would actually be able to be just sucked up with this syringe. I think what I'm going to do, I'm going to come up with a way to hold this vertical for me. Alright, so I'm using my vise laid on its side here, and I've got this in here. It's holding it well enough so I shouldn't have to worry about it falling over on me. It's funny, I actually didn't think that was going to work. It worked better than I thought it would. Alright. This grease is still thick enough that this weak little syringe can't really get enough draw to draw the grease up into the tube. It did it the first time and now it won't do it again. Alright, that actually doesn't seem too bad. I'm just going to don a glove so I can use my thumb and just push what's on the top here down inside a little bit. This is not squeezing out the back side here, but I filled that groove all the way around. So if I fill this groove all the way around so that it squeezes out all the way around here, then I believe at that point it will have been overpacked. So we're not going to do that. It feels and sounds good. Alright, I think maybe on this one we'll try method number 2. So method number 2 is scoop some up onto your finger. Not too much. Press it in. And I've got just about third covered there. Now, of course, I got so much on my gloved finger that I can't tell whether or not I actually have it squeezing through the other side, or is that just where I touch the other side with my gloved finger? I think that's going through. Method number 1 there with the syringe actually seems to be giving me a smoother action out of the bearing. I'm going to push a little more in on this bearing, but I'm going to put it on the other side. See how that seems a little better. Yeah, I know, I kind of gave up on the gloves. If I had a properly sized syringe that could actually go down into that little opening between the cage and the sidewall of the bearing there, that might have made the syringe method work better.